So students, today I will take this case of Faraday's law of electromagnetic induction. तो फैराडे ने बहुत अच्छा एक फार्मूला और एक फिजिकल साइंस का एक इंफॉर्मेशन दिया कि देयर कैन बी करंट इंड्यूस्ड इन अ सर्किट इन अ वायर इवन विदाउट बैटरी. बिना बैटरी के भी करंट का प्रोडक्शन उन्होंने किया बाय वेरी स्पेशल मेथड, वेरी जेनरिक मेथड, दैट इज रेट ऑफ चेंज ऑफ मैग्नेटिक फ्लक्स. मैग्नेटिक फ्लक्स को कितना फास्ट हम चेंज करेंगे उतना ज़्यादा magnitude of EMF and current will be produced in the circuit, meaning that just by the flux change without any external battery we can generate current in the circuit. And all the hydropower projects, सामने का होगा कि भाखड़ा नांगल डैम प्रोजेक्ट, रिहंद प्रोजेक्ट, all that river valley projects where water is stored and that potential energy of stored water is being converted into electrical energy. And there are two things simultaneously. The benefit, one is the generation of electricity, and that stored water we can channelize for the irrigation purposes in across India. Correct. So without any battery involvement and without any pollution as such, we can create this current. तो उसको हम लोग यहाँ पे define करते हैं, that is called as Faraday's law of electromagnetic induction. Electromagnetic induction, it is the Faraday's law of electromagnetic induction. This we have to see. Actual में what happened, Faraday was the scientist, he was doing some experiment, वो अपना कुछ experiment कर रहे थे and he had a device, मान लो ये galvanometer ऐसा कुछ था, उनके पास ऐसा कोई device था. Simply there was a galvanometer and there was a closed loop. What this Faraday did, he was doing some experiment, could not get any substantial result. Out of just dejection, he just thrown a bar magnet across this loop. उन्होंने इसको इसके across just simply ऐसे throw कर दिया. What we found कि just by throwing the magnet across this conducting loop, say it was of copper wire and something etc. What he found, there was deflection in galvanometer. He again threw on the loop कि भाई maybe by chance it could have come. Again there was a current induced in the loop. See, there is no battery, only galvanometer is present. Still by the movement of magnetic material, this magnet, bar magnet, across this loop, there is induction of current. Correct? So this phenomena of induction of current here by the motion of bar magnet. This is your bar magnet. This is bar magnet. So once this bar magnet is moving across this, there is a production of current. Faster the change, more is the magnitude of current. This thing is also happening. So current induced, and this bar magnet, what it will cause? It will cause the production of field lines. These field lines, they are interacting with the loop. Correct. इसमें क्या change होता है? There we see the flux change, phi. Phi is equal to B into S into cos theta I can take. This is called as magnetic flux. It was related with the concept of magnetic flux. Whenever there is a magnetic flux change, there is a tendency of induced EMF in the loop. Correct. And this magnetic flux is the product of magnetic field associated with the loop, area of the loop. This is A for S for area, and theta, cos theta. Here theta is angle between the magnetic field and S vector. S is the area vector. For that we see the change. Now just see, these are the magnetic field lines, they are associated with the loop. This loop will have some certain area for the circle and some orientation also happened, meaning that a bar magnet is kept here as such, and this loop I am slightly tilting. The tilting of the loop will also cause the flux change because theta is changing, but the net flux will change. So phi can change by three factors. If you see, B into S into cos theta. Either there is a change of B, or there is a change of area, or there is change of theta. Any of the three factor change can bring the flux change. Any of the three. Maybe the two are simultaneously changing, maybe all the three are simultaneously changing, but anyway, if any of them is changing, so there is a induced EMF. The rate of change of flux d phi by dt it always given the concept of induced EMF. E is called induced EMF. It is induced EMF in the loop. In this loop, there is a production of induced EMF. EMF means potential difference created across this battery. And once the loop is having some induced EMF, what we have, it will also have some current in the circuit. Say the total resistance here is R. R is the resistance. I can say the induced current in the loop, and this induced current will be EMF upon resistance. So this way we can get the induced EMF and current in the circuit. ये दोनों वैल्यू आपको यहाँ पर मिल जाएगी, करेक्ट. So this thing we can see. R is the resistance. This R I have said it to be a resistance. It is resistance. Correct. The EMF upon resistance, this is the current induced in the circuit. So this process we'll see. And faster the change. If magnet is moved faster, more is the induced EMF and current in the circuit. It is going slow, less is the induced EMF and current in the circuit. It is just put at rest. Even though flux is changed, flux is constant. Being flux constant doesn't create EMF. It has to be changed. तो आप यहाँ पे ये चीज देखोगे, करेक्ट. Further, if I see this magnetic flux, this I have defined earlier also in Gauss law. So this magnetic flux is the product of three things. B dot S. Actually, we say it is B dot S. It is a dot product. Means magnetic flux is a scalar quantity. ये क्या है? It is a scalar quantity. It is a dot product. Correct. And further, I have said it is Bs into cos theta. How it can change the EMF? All that factors we can see. Now, suppose I say there is a square loop here. I give you one example. Say it is a square loop of side length, say 2 meters, and it is present in some magnetic field. Say some magnetic field is present here in the surrounding of square loop, and this magnetic field is changing with time. Suppose I say B value is 3 plus 2t, means magnetic field is changing with time, and it has some resistance also. I say the resistance is 4 ohm. 4 ohm is the resistance. So due to the flux change, just see, this is a magnetic field and flux change tendency is happening. The induced EMF, I said, it is equal to d phi by dt. Now if I see here, so what is causing the flux change? Just see the rate of change of field. Rate of change of field. And the area vector associated with the loop, I can say it is outward. And magnetic field is inside. If I apply this concept, so I will say that d phi by dt. Here, what I will write? It is dB by dt, rate of change of field, into area associated. Area associated, if it is said to be a square loop, it is 2 ka square. So, what I will get? Just see, the induced EMF happened dB by dt. If you differentiate this term, it is 0 plus 2 into area. Area is 2 ka square. It is just 2 squared. So this EMF will be, just see, it is 8 volt. 8 volt is the EMF created. So this loop will have some EMF. Now we see with the time increase, B is increasing, so flux is also increasing. These three factors, they can be correlated. With the time increase, how this term they are related, correct? The flux is increasing. It has some resistance also. It will cause us some current produced in the circuit. That is EMF upon resistance. Now resistance is 4 ohm. Now put the value here. What I get? 8 by 4. It is 2 ampere. So 2 ampere is the value of current induced in the circuit. What shall be the direction of induced current? So that direction of induced current can also we can obtain. How? The induced EMF and current, this say current I dash, I say it is induced. I dash will create a field, a magnetic field. It will create a which field? Magnetic field, which will oppose the flux change. This is very important statement. I dash will create a field, magnetic field of its own, which will oppose the flux change. Here flux is increasing. So I dash will create a magnetic field which will oppose the change, which will oppose the increase, meaning that it will create a field B. Here the field B will be, if it is opposing, so this field has to have the direction outside. Initial field was inside, so this will be outside. The field B induced, if I say B dash induced, is outside the page. It is outside the page, above, outside the page. To make it happen like that, we apply the right hand thumb rule. I will say field is outward, the current will go in the circuit like this. So this is the direction of induced current I dash. I dash in the circuit will be anti-clockwise. So this I dash here, if I say it is anti-clockwise in direction, because flux is increasing, magnetic field is also increasing, the induced field will be opposite. So it is outside the page. To make that happen, your current in the loop will be anti-clockwise. So these results we can see. This is the basic of Faraday's law of electromagnetic induction. Correct. And opposition, how it is happening, that also we can see. Correct. Is loop mein how we got the result. Further what I am saying, this Faraday's law E is equal to minus d phi by dt. Generally it is written as minus of d phi by dt. Minus sign implies that, this minus sign implies that induced EMF and associated current I dash will always oppose, they will always oppose the flux change. They will always oppose the flux change. Correct. Meaning that what I will say, if flux is increasing with time, B dash shall be opposite in direction. B dash shall be opposite in direction. ये आप मान लीजिएगा. And corresponding to B dash, you will guess the direction of I dash as per the right hand thumb rule. If flux is decreasing with time, suppose it has this tendency, so B dash is in same direction of initial B present, and correspondingly I will get the direction of induced current. So this thing we have to see, we have to analyze and always get the result. The opposition, this term tendency. Even this minus sign defines the Lenz law. This also defines the Lenz law. What is the Lenz law? Lenz law said that induced, why the same thing, induced EMF and current in the loop, they will oppose the flux change. That is the Lenz law. The minus sign of Faraday law of electromagnetic induction. This is the Faraday law of electromagnetic induction, for which the minus sign, for this law the minus sign defines the Lenz law. Correct. वही चीज होगा. And also I say this Lenz law, it is based on conservation of energy principle. Conservation of energy principle. Correct. These two things are important. It is based on energy conservation principle, and the induced EMF current, they will oppose the flux change. For this case only we can say, though all the hydropower projects, they are storing the water, they are storing the gravitational potential energy of water in that big dam. Their mgh, height of center of mass of the water, the total lakhs of crores of liters of water is placed there, and the stored energy is made to fall to rotate the turbines. Turbines are rotating, but the stored potential energy of water is converted into rotation energy. They are rotating turbines, mechanical energy. That mechanical energy causing the flux change, rotation say, and that flux change create the induced EMF. Primarily you can say all the stored energy of the water in the dam is converted into electrical energy. Correct. Energy conservation principle is followed. So these two things we have to keep in mind. Correct. Meaning induced EMF current will oppose the flux change, and we will see so many factors how does it go, and keeping this flux as a scalar quantity also we have to see. Okay. Now, the alternating current which is coming to our household, voltage, all that is due to this Faraday law of electromagnetic induction. Okay. Now, suppose I say there is the change of flux somewhere, it can be like this also. Suppose I see this the square loop of side length 2 meter it was, and there is a magnetic field just present, external magnetic field is present, and this external magnetic field B has a value say 6 units. 6 units of magnetic field, that is constant. Now this loop, what happened? It changes its shape. How it is changing the shape? Suppose it converts into, this loop converts into circle. Anyhow, it took the shape of circle. The square is converting, square shape converts into circle by some mechanism or internal mechanism. What could be the induced EMF? What could be the current? And amount of charge flow also we can see if the time interval mentioned is here. Okay. Some time it is taking, and for this sake, if retaining the shape of loop, circular loop, the time interval is 2 seconds. मान लो हमने ऐसे assume कर लिया. What the values it can have? Just see. Square is converting into circle. Means circle has more area. Circle has more area. For a given length, circle has the maximum area. If it has more area, means field are remaining constant. So area S is increasing. मतलब B is constant, so flux will increase. So if flux is increasing, and it has some resistance, say it has some resistance also. If flux is increasing, the B dash, by B dash induced will oppose the flux increase. The B dash shall be opposite, and B dash shall be opposite to this present field. So that means it is coming outside, and correspondingly I will guess the direction of induced current I dash. I dash, you see right hand thumb rule like this way. The right hand thumb rule, I dash is anti-clockwise. Anti-clockwise the direction of induced current, and we can see the value. Now how the area is different. Initial area, if I say, of the loop was A square. A square is 2 square. 2 square. So it is 4 square meter, I can say. Final area if I have to see. Area final if I have to see. First of all, I will convert the circumference length 2 into 4. The side length is equal to 2 pi r. 2 pi and r is the radius. So what you will get? The final radius r you will get it to be, here the r value, radius you will get it to be how much? 4 by pi. 4 upon pi is the radius. So area final is pi into r square. R square is 16 upon pi square. Correct? This value we have 16 upon pi square, one of the pi got cancelled. So it is 16 upon pi. 16 upon pi is the final area. देखो ये this area is 4 and this is 16 upon pi 3.14. This area is larger. So the EMF happened, that is the magnetic field. Magnetic field value is B is 6 into area final minus area initial upon time. This will create the EMF induced in the loop. Now for the EMF upon resistance, EMF upon resistance, that is the induced current also you will get in the circuit. Even with the shape change, no magnetic field changing the magnitude, we can get the value of induced current developed. And this is the proper method how we are getting it. Correct? So flux change can happen even with the shape change. And if vice versa is happening, but again the circle is going into square shape, so again the direction will change for the magnetic field because area is decreasing. The induced current direction will change. If there is a continuous process of converting from square to circle, circle to square, induced magnetic field direction can be opposing in nature and correspondingly we will get the direction of current flow. Correct? So this thing we have to have, keep in mind. The flux, how many factors they are involved for the change. Now I said it can change with the change of this value of B or area or even the orientation theta also can change. So you can see the flux change by theta change also we can see. Now flux change by the theta change also we can see. If flux is changing by theta change, how does it happen? Suppose I say this is the loop, say square loop, and it is present in some field. Field is like this, and it is oriented this way. This is a line, and this is rotating with certain omega. Say side length is 2 meters. Magnetic field B, I take the same as 6 units. And this field is present throughout the surrounding. Everywhere this field is present. If this field is present, what we see due to this field effect, it is rotating with certain omega. So right now the flux is maximum, I can say, because magnitude of flux, if you see, area vector is outside, field is inside, cos 180 minus 1, magnitude is plus 1, the flux is maximum. So right now the flux, if I have to see, because it is rotating with certain omega, is it for any change, cos theta factor will come, this, and it is rotating. So it by angle 90-degree change, flux will become 0. Initial flux is maximum, means this flux will follow phi naught cos theta concept, because initial flux is maximum and at theta 90-degree change flux is getting 0. So I will say that phi is equal to B into area. Area you see 2 square, and theta I will write omega into t if omega is remaining constant. I take this term omega as constant. If omega is remaining constant, it is the term B into cos omega t. This value we have for the flux. Flux is B. So you see the effect 4B into cos omega t. This result we have, the flux change. Now for the flux change, there will be induced EMF. Induced EMF, what it will be? It is minus d phi by dt. If I apply this result, minus d phi by dt, what? Cos theta, differentiation is minus sin theta, the minus sine, and cos theta values, and 1 minus is here. So 2 minus they are making it plus. So 4 omega b sin omega t. This result we have 4 omega b sin omega t. And this term I will say it to be the phi naught. Correct? EMF induced in the circuit is this function of sine. So I will say that EMF induced here in the circuit will following the sine function E versus T. It will go like this. It is the basic of alternating EMF current generation. And if we have the EMF with time as a sine function, just see here, na? And the peak value of current is this. EMF is there. EMF upon resistance will give current also. The current will also follow the sine function. If I have to draw the graph for current in the circuit, that will also be sinusoidal. Correct? So this sinusoidal value will happen. I can say equivalent way, the current can also come like this sine function. So this is current, alternating current, varying with time, and EMF. So both are results with the flux change. Any rectangular loop and like that. The same method is being applied for generation of all the hydropower projects. Flux change, and there is, you see, there is no battery as such. Just by the fast rotation of the loop, these are the current carrying coils. We have done in the last classes how the current carrying coil, it rotates and it can create the value of flux change. Correct? EMF and current, they are following the sine function. With this data, what I have done. Correct? ये रिजल्ट भी आप लोग कर सकते हैं. तो हाउ EMF is going for this flux change and theta change. Theta change से ये flux की change की value आ जाएगी. We differentiate the function and the what we see here, the rotational effect is creating the production of induced current in the circuit. Okay. Now, one more factor is there, that is the flux change delta phi creates EMF, and further I say that E by R, that is the induced current in the loop, and further I can say induced current into time, say delta Q, amount of charge flow. This is the amount of charge flow in the loop, charge flow in the loop. This value also we can guess, no? The amount of charge flow in the loop, that term also we can get, correct? ये भी हम लोग देख सकते हैं how the charge flow is happening, a result. How you will see, just see the effect. Now the flux change E is equal to delta phi by delta T, that is the flux change we got. EMF upon resistance 1 by R, that will give the induced current. So if you see, I dash is delta phi by delta T times 1 by R. This thing is happening. Now I dash into delta T, if you see, that is delta phi upon resistance. I dash into delta T is delta phi upon resistance, and this I dash delta T is called amount of charge flow in the loop, and it is change of flux upon resistance. So this value is also quite possible to see the flux change effect and amount of charge flow in the circuit, ना? तो charge flow in the circuit क्या आएगा? That value also can be seen. Okay, this thing can happen, meaning that the charge flow results. Suppose I say there was the square converted into circle, just see, square was side length 2 meters, and it is present in some magnetic field B of 6 unit, and time taken here is, if you see, say 4 seconds. If I say time taken is 4 seconds, amount of charge flow, the amount of charge flow, that also we can get, because charge flow is changing flux upon resistance. So delta Q, changing flux, magnetic field is mentioned, into area final, S area final minus area initial upon resistance of the loop. This resistance will be mentioned. Suppose this resistance R is 4 ohm. I can put it as 4 ohm. The B value I am putting as 6. Area final is pi R square for the circle. Area initial is only the side length 2 ka square upon 4. So this way we can get the value of charge flow. What the tendency of charge flow also, that we can guess, because here the flux is increasing, so induced current, if I see, and this field was initial field, say it was inside, this field, initial field was inside, opposing field B dash will be outside. To make the B dash outside, the charge flow in the ring shape figure will be this. So delta I dash induced is this way, and charge flow will be I dash, you see the direction, I dash is anti-clockwise. I dash is the anti-clockwise direction mentioned here. So current and charge flow, how they are related, that term we can see. Okay, तो ये रिजल्ट भी हम लोग यहाँ पर देख सकते हैं कैसे आया, that pattern you can relate. Okay, now further what we have, once we have this thing, flux change and area, one interesting question I can relate further, just see. Suppose I say this is a straight wire carrying current I, and there is a square loop of side length 2 meters, and this one end is at a distance of 1 meter. This is a square loop. So what is the flux with this loop? Sometimes we can see the question like this. We have to find the flux associated with the loop. Now see, field is happening due to this wire, due to this infinite long wire current, some field is happening. What you will find, this field doesn't remain constant everywhere. It will vary as a function of x. I can take some element at a distance x, and extension is dx. So I will see the d phi flux. The d phi flux is field due to the infinite long wire, mu naught by 2 pi into I by x. This is the field at a function of x. Now area I will take, side length is 2 dx, and I can integrate the function. I can integrate this function also. You can get the value of flux phi. Phi value what you will get, just see, this mu naught I by pi. This 2 got cancelled, this 2 and this 2 got cancelled. Mu naught of pi I integration of dx by x. If I solve, it is log x. So this value is mu naught I upon pi ln x. This result we get for the flux associated. Now we'll see the values of x, how it is varying. First end 1 and second end 1 plus 2 is 3. So this is varying from 1 to 3. So I'll get the flux associated. It is mu naught I over pi ln 3 minus ln 1. Now this thing I can do, and further the results can be seen. I will say that this flux phi is mu naught I by pi ln log A minus log B, this ln 3, correct ना. This term we can put, ये रिजल्ट हम लोग ले सकते हैं, ठीक है. तो flux associated is happening. Now one more interesting case can happen if this is rotated. This arrangement is rotated by this line. Agar if it is rotated about this line, what is the flux change and phi value? Suppose I say this is the line I am mentioning here, and it is just rotating by 180 degree. Say this point was P, Q, R, S. P, Q, R, S was the loop, and its side was like this. And you have seen the field lines, how they are related due to I, B will be inside. And this flux, this result we have. Now it is being rotated by 180 degree. Once it is being rotated by 180 degree, what will happen? Just see. This result is clear. If it is being rotated, what you will find, just I am changing this the terms. I will change bit of this term, और इसको मैं निकाल चुका था, this flux value. Just see the initial flux, how it was. Phi को I put it here, phi is equal to mu naught I over pi ln 3. This is the first condition of flux. Now it is changing, and by rotating by 180 degree effect, say loop is coming here. Once the loop is coming here, the P is becoming P dash backward. S is becoming S dash. Correct? So what is the final flux right now? The final flux right now, what will happen? If you apply the same result, it is what? Mu naught I by pi ln. Now, this distance, if you see, here it was 1, here it was 3, 3 plus 2, 5. It is changing from ln x. This value of x is changing from 3 to 5. Just see, 3 to 5. Here this end, first end about this axis, this is 3 and this is 5. It is changing from 3 to 5. Just see. Now one more thing will happen. It is rotating and phase is also changing. I'll put a minus sign due to 180 degree effect. What is that? Just see. Say this is the arrangement I'm putting here. This is the line, and magnetic field due to defined long wire. This is the blue color page, and if it is rotated like this, it is becoming yellow. So this area vector is for positive. So this area vector will become negative for the same magnitude. That's why I'm putting this minus sign. So phi 2 is this. Phi 2 term, we got it like this. So the flux change, phi 2 minus phi 1, what it will be? Now just see. Here this effect, if I have to go, see, What is phi 2 here? Phi 2 will be minus mu naught I by pi ln phi by 3. If I remove the minus sign, I will say it to be as mu naught I by pi ln 3 by 5. Correct? Ln 3 by 5. What was phi initial? Phi initial was mu naught I by pi ln 3. Correct? This term we have. So, if I go with the terms phi 2 minus phi 1, it is phi 1 and it was phi 2. What value I will have? Just see, mu naught I by pi, just see, ln 3 by 5 minus ln 3. This result we have. Correct? Na? So, further result, what can I write? If I write the further result, log A minus log B, log A upon B. Na? So, this is the flux change, and delta phi I will write it as, if I highlight it, correct? So, delta phi will be, just see, mu naught I by pi, the result, and ln 3 upon 5 by 3, ln 1 by 5. Na? This result is there. So 3 got cancelled. So ye and the final value, for that I am taking the positive direction. It is like this. So ये result आपको यहाँ पे, this thing we have. If I put it there, minus sign into consideration, it can also become minus ln 5. ठीक है? So this way the flux change we have seen. And for this flux change, if I have to see the charge flow, the delta Q also I can get. So this delta Q will be the flux change upon some resistance. If it is mentioned some resistance R, I can say delta phi by R. You can also see the value, results, how they are happening. Correct? The plus minus sign and flux change, it's a good example for seeing the result. Correct? Just see. Now, for the flux change effect, I have seen in detail. Now I will go for the Lenz law. Application of Lenz law, I will see. What is this application of Lenz law? That we can also see in detail. How this Lenz law work and its application we have. What could the direction of induced current in the loop? See, what happened? One more case I am taking. This is the U-shape long wire arrangement. It is having some resistance R, and there is this rod which can go on the loop. No? This can go, and there is a field mentioned here. That this magnetic field is present. Resistance of the loop is R for this arrangement. Say it is having, this rod can slide in this arrangement. It has the mass M and length L. If the rod has mass M, length L, and is made to rotate, made to slide with a velocity, initial velocity say V0. If initial velocity is V0 and it is made to slide in this direction, so what could be the induced EMF in the loop? All the things we can see. I can take the arrangement to be as PQRS. Say this is PQRS. The PQRS is the rectangular loop arrangement. It is happening and due to motion of the rod, the flux is increasing. If I say with the time increase, flux is increasing. For if flux is increasing, how do we see the induced EMF and current? ना? तो वो चीज हम लोग देख सकते हैं. First of all, there can be mentioned if V0 is to remain constant, what shall be the minimum force to be applied to make the velocity of the rod as constant? See, if the rod velocity is kept constant, first of all we have to see the magnetic flux change tendency. The flux is increasing because after a certain time this can come to a next point. The rod is reaching the next place here. say Q to Q dash and R to R dash, there is a delta X change. So area will change by this factor, and this area change I can see. So flux is increasing with the time. So what you will see, the induced field B dash will be outside the page because it will oppose the flux change. If it is outside, so the current induced in the circuit will be anti-clockwise. I dash will be anti-clockwise. So this thing I can guess. So what you will see, this moving rod will have the tendency of current flow this way. So induced current will go like this, I dash. For this I dash, I can see the polarity generated in the moving rod. This is this, because it will make the current come out from the positive end. So this is the positive end, this is the negative end. This arrangement will be followed and induced EMF will be developed. See the flux phi as a function of x, I will say B into L into x. If it is a function of x and delta x is the change. Now I see the EMF, it is d phi by dt. If you write it here, it is BL into dx by dt. And here this dx by dt they are writing to be V naught velocity as a constant. So BL V naught. This velocity of rod is kept constant. This is the induced EMF in the loop. As per the Faraday's law, induced EMF is BL into V naught. Correct. Velocity is perpendicular and L is the length of the rod with the mass m. Now if it is like this, induced current also I can say I dash, this EMF upon resistance R I can write. So it will be BL V naught by R resistance. This is the induced current developed in the circuit. Okay, induced current I will see. Now I was asking, what shall be the force to be applied? What shall be this force to be applied so that velocity remains constant? Now see, this rod having the current I dash like this, the magnetic force due to induced current IL cross B, rotate the fingers of right hand, IL to B, force will be in opposite direction. Magnetic force will come here. This magnetic force will have tendency to decrease the speed of rod. So to keep V naught constant, my external force shall be opposite to the magnetic force. It shall balance. So if magnetic force is this, my external force will be in this way, in the direction of velocity. So that way also I can write this force F external value I can see, this external force acting on the rod, that if you have to see, that will be I dash into length L. So you see B I dash into length L. I dash is, first of all I write B and I dash is B L V naught by R into length L. This is the term for the force. So this force will happen to be what? Is B square L square V naught by R. So this is the force required, minimum force to keep the velocity of the rod as constant. Force value I get it. How this thing is happening? Magnetic force happened. Now I can also relate one term here. This is the force power. If I have to write the power, power is F dot V. Power generated will be F dot V naught. I can see the power value also in the circuit. What is the external power to be given? Mechanical power to be given in the circuit. That result also we can see. So this power, if I multiply with the force, that is what? It is B square L square V naught square by R. That is the power. The external power shall be like this: B square L square V naught square by R. This is the power. Now see one more term. This E is what? E is B into L into V. So I can say the electric power generated in the circuit and mechanical power both will remain same, E into V if I apply. Nah, just see. It is the EMF. Okay. For this EMF and the result, if I put it in the next page, just see. What I am saying, EMF is BL V naught and power external, that was B square L square V naught square by R. Now from here, the electrical power, if I go for the electrical power is EMF ka square by R. So this value is what? It is B square L square V naught square by R. What can I say? The mechanical power in the circuit, power mechanical by external agent, is being converted into power electrical. So both the results are same. Mechanical power, you see, it is B square L square V naught square by R, and it is E square by R, and that is also the same value we have here. Meaning that this Lenz law is based on energy conservation principle. Means mechanical energy is converted into electrical energy. That I have defined, correct? So this thing is based on that arrangement key. How the mechanical energy supplied by external agent is being converted into electrical energy. So mechanical energy can be converted into electrical energy. This result we have here. Further, the same way, one more case I can take. Just see. Suppose example 2 I am saying for Lenz law. This is mechanical energy and that way. Suppose this is a U-shaped figure in the vertical plane, and there this rod moving. Again this rod is of length L and mass M. It has the mass M, length L. There is some magnetic field present like this. This is the magnetic field present, and this is the resistance R. If the rod is sliding down under the gravitational force, G effect force is acting downward. If G effect force is acting downward, so this rod will have tendency to fall under the effect of gravity. The vertical plane, the field lines are horizontal going inside the arrangement. Again, I take that P, Q, R, S. I take this resistance R dash for resistance and R for this arrangement, correct? It is coming down, the flux is again increasing, because after certain time you will find the rod has moved to next distance. So the rod is again changing as a function of x. If I say it is this, the rod is changing the position, and this rod will fall down. What will happen? Initially with time increase, flux is increasing. Now the induced EMF will be causing such that B dash is opposite. So current I dash also I can guess in the arrangement. I dash also I can see that is anti-clockwise. No, it is anti-clockwise. This value we have. Now this flux is changing. I will write for the flux as a function phi. Phi will be B L into X. So this rod will have some velocity under the effect of mg force. Mg force will act downward, and some magnetic force on the rod will act upward. This will oppose the mg force. How so? Because you see current is anti-clockwise. So current flowing in the arrangement is like this. So ideal cross B say you see magnetic force is up and gravitational force is acting downward. So flux is like this. For the flux change, magnetic forces they are being given. I will say the d phi by dt. So d phi by dt, this value is B into L into dx by dt, that is the velocity. For any time the velocity is BL into V. So function which is creating the EMF, it is this. Now for the EMF I can also say the current induced I dash, it is BL V by R dash. So this is the current. So at any instance what will happen? The magnetic force F magnetic, I can see the same pattern, B I dash into length L. This will be B square L square V by R. This is the magnetic force. The magnetic force is this. Initially what will happen, you see, initial velocity of the rod is 0 because this is just allowed to fall. Initial velocity is 0 means with the time increase, I can say with the time increase, velocity of rod will also increase. This factor I can say. The velocity of rod is increasing means magnetic force will also increase. The magnetic force is a function of velocity. Magnetic force is a function of velocity. So with the rod speed increase, time increase, one stage can happen. One stage can happen when the the force, magnetic force acting on the rod will balance the mg force. Mg force acting on the rod will balance the magnetic force. Both can balance each other. Correct. Both the values can balance. What could be the maximum speed attained by the rod? I can see. Till this time, the force mg force is greater than magnetic force. The maximum speed attained, I can also say it can have when F magnetic will be equal to the mg force, and F magnetic will be B square L square. V maximum is Vm square, Vm, only Vm I will write, by R. I can see R dash is the resistance. Okay. I can say the value of this term maximum speed attained, that will be just see mg R dash, mg R dash, I can say over this term value will be B square L square. No? So this is the maximum speed attained by the rod. The maximum speed attained by the rod is this mg R dash over B square L square. For the subsequent motion of rod falling under the effect of mg force and magnetic force, the maximum speed is this. Till the time rod is attaining the maximum speed, ये ध्यान दीजिएगा, mg force is greater than this magnetic force, and maximum speed attained is this. For this maximum speed, your value this I have derived. Now, sometime it may be asked, what is the velocity of the rod as a function of time t? That also I can write. In this case, can also be the case, find velocity of rod as a function of time t. What is the velocity of the rod as a function of time t? This value also we can do. Now see, the same figure I am writing. This is the resistance. Rod is coming down, falling down under the effect of mg and all the forces. What we see here? Just see mg force is acting down, magnetic force is acting up. Magnetic force is acting up. This R is the resistance in the R dash I was putting. I will say this mg is more than F magnetic, and that value is equal to m into A. This thing I can write. So velocity as a function of time t. For that I will write like this. Now see that this mg force minus magnetic force is B square L square V by R. Now it is this B square L square V by R. This is the magnetic force. That is equal to m, and A is dV by dt. For this term I write it as A is equal to dV by dt. Further what I have, if I write the term A is dV by dt, correct. Further I will say it is G minus B square L square V by R dash m is equal to what? It is dV by dt. This term we have. Further if I write, what I will go? I will write it as dV over G minus B square L square V by mr dash integration, and this value is dt. Now this term we have, just see dV over this term, and this value will get dt. Further, if I solve, so what the result I will get? Just see, आप देखेंगे. Here I am writing it is integration of dv over m r dash into g minus b square l square v, this m r dash, and this term what I will get into m r dash, it is equal to dt integration. This result we have. Subsequently it will give the value for what? Exponential terms we can get further. If I write, I will say it to be as, just see, I will write it as integration of dv over m g r dash minus b square l square v, and this value is equal to 1 upon m r dash dt is t. Integration of dt is t, I can write, and this term will be log function ln mg r dash minus b square l square v. Now with the coefficient divided here, the term what I will have into this effect, this will get divided 1 upon b square l square. Okay, and this term will be what? T upon m r dash. This value we have. For the log values, I can put the results and further solve. I can get the velocity of rod, exponential form and logarithmic form. Both the results can be obtained. The velocity of the rod as a function of time t, that I can easily see. Just see, the velocity of rod as a function of time t, what I have used here, you can apply it and get the results. Further limits we can put. No, further limits we can put. Initial speed was 0, and what it is happening, all the results we have. If you want, certainly I can do it here again with the same results I am putting. Let me complete it. No? I am trying to complete the whole term, how it will go. Just hold on. I will just put it exactly the values what I can get. See, what I have here, the values are ln, just see, it is mg r dash minus b square l square v times 1 upon, this term is b square l square with minus sign, and this value is what? T by m r dash. See, further I will see ln mg r dash minus b square l square v, minus sign putting there, it is minus of b square l square by m r dash into t. This thing I have. Now with the result, for t is equal to 0, for t is equal to 0, velocity of the rod is 0. For any time t, velocity is v. So I will write it as ln mg r dash minus b square l square v log a minus ln mg r dash log A minus log B, correct, is equal to minus B square L square by MR dash into T, correct. It is this. Further I will write it to be as ln mg r dash minus B square L square V over mg r dash log A minus log B log A upon B is equal to what I have. It is minus B square L square by MR dash into T. The logarithmic function. Further I will convert into exponential. So this result, I think you got the idea. How do we approach the velocity? A bit of math was there, but it's good if you put some maths into physics and get the results. The velocity of the rod for exponential functions, we have it like this, correct. ये चीज आप देख सकते थे. Now all this was for the charges for any flux change that I have seen in a resistor. In the resistor, how this flux is changing, that I have defined. Other case can also be there for the rod as a capacitor. Suppose I say there is a capacitor arranged and this rod is moving in the effect of some capacitor arrangement, correct, and there is some field, capacitance C, magnetic field is B, and this rod is given some force constant is given on the rod, correct. If some force constant is mentioned, this rod has mass m and length L, you can find out the acceleration of the rod as a function of time t. It can be said to be find out acceleration of the rod as a function of time t. It can also be one of the question applying the Lenz law and all. So what I will have, say this force is creating to make it move in this direction. Actually flux is increasing. The system will try to oppose the flux change. So anytime the rod is reaching the next position here, x is changing. Say it is delta x like that. The flux as a function of x phi is B L into x, I can see. The flux change EMF E is d phi by dt, I can see it here. That is B L dx by dt will be the velocity. The velocity of the rod we can see. Now this moving rod will create a EMF. This EMF will go like this. This is the negative terminal, this is the positive terminal of the battery. This will create a EMF E. And E is equal to BLV. For the loop rule, if I apply here, what I will see? The polarity of the capacitor will be plus to minus and some charge will be developed here, say Q. So what I will write, just see, E minus Q by C equal to 0. This is the loop rule I can apply. E is what? BLV minus Q by C, it is 0. So I will say it to be as BLV is equal to Q by C. Or further I can see charge in the circuit is BLV into C. The charge developed in the circuit will be this. As a function of velocity it is. So if I have to find the current in the circuit, current will be dq by dt. So if I see the current, dq by dt is B L dV by dt into C. Further I will say this B L A is the acceleration to C. This is the current. The current in the rod, it's BLA into C, function of acceleration. So at any stance, what can I see? The force is acting. There is a magnetic force because the tendency of charge flow is like this. The magnetic force is in this opposite direction. The magnetic force will be what? F magnetic force will be in opposite direction. That is B I induced I dash if I say into length L. So this I will put it as B into L and I dash is B L A into C. Correct. So this is the magnetic force. So this magnetic force value will be B square L square A into C. This is the magnetic force. What I have further, F external minus F magnetic, that is M into A. Now, acceleration of the rod as a function of time t I can write. F is this minus F magnetic is B square L square A into C, it is M into A. Correct? I will say that this F is equal to A into M plus B square L square into C. Now, the acceleration of the rod I can get from here. So, if I have to see the acceleration of the rod, what I will get? See here I can see acceleration of the rod, that will be F upon M plus this value is B square L square into C. So this is the function of acceleration of the rod. Now see the acceleration of the rod. Now this acceleration of the rod, you see F upon M B L square C. All the terms given here, they are constant. So this acceleration will also remain constant. The acceleration will remain constant. So if acceleration is constant, I can say the velocity V is equal to U plus AT will be correct in the given parameters. Even S is equal to UT plus half AT square. This formula can be applied here. For the capacitor with the moving rod, I have explained what the values we have. कैसे इसको कर सकते हैं, एक बार आप चेक कर सकते हो. How this result is happening for the capacitors and this effect. Okay, the flux change can have by different factors. On some of the cases I have explained. Further, we will see some cases of motional EMF. It's also one of the important case that we will do in the next class. Thank you.